Hello and welcome back to the Robotics in a Nutshell series, sponsored by RS Grassroots and prepared by humanoid. This tutorial is the second part of the Computer-Aided Design or CAD section of the series. In this section, we will go over the creation of this 3-segment finger, which will be actuated by a tendon passing through channels and connecting to the tip. Today, we will finish the design and assemble it virtually. Last time, we finished the midsection. Now, we will use some more tools to quickly create the other two, starting with the tip. In the bottom bar, we can see the environment we created for our part, which is called a part studio, and the environment where we will assemble our parts later, which is called an assembly. We will now create a new part studio for the tip by clicking on the plus button and then Create Part Studio. Let's start with the side sketch. We will now create a semicircle using the arc tool to the right of the circle. Our first click defines the center at the origin, and the next two, the start and the end of the arc. Let's set the arc radius to be 6 mm. We don't need to set constraints to the ends of the arc, since they are automatically set when we snapped the end to the vertical line. Now let's add 3 lines to close the profile and set the length to 12 mm. We will add an extra vertical line 7 mm from the origin to isolate the front profile. Now let's hide the planes. We will extrude everything symmetrically by 7.75 mm, so there is a small clearance between the tip and the midsection. Now we will remove some material from the center so it's a bit more flexible and easier to attach to the midsection. This is done via a symmetrical cut extrude of 3.75 mm. We will add some small fillets to make the side walls just a bit stronger. Next, we will add the pin of the joint. Since we use the origin as our rotation axis, we can just use the front plane for our new sketch. It would be nice if we could somehow include the geometry of the model in the sketch so we can base our pin position on it. To do so, we will need to use the project command to the left of the construction line command. Now all we need to do is to select the edges we want to be included and they will become lines in our sketch. Now, we will create 2.5 mm radius semicircles for the pins and add a horizontal line through the axis. You will see why later. We will also add vertical lines 1.5 mm away to isolate a slimmer pin profile and make them a bit easier to snap into place. Now that our sketch is complete, we will use an important 3D modeling tool to create the pins called Revolving. As the name suggests, instead of extending a profile perpendicularly to its plane like with extruding, Revolving rotates it about an axis. Let's select our pin profile and revolve it around the axis we created earlier. As you can see, this way we created geometry that cannot be created via extruding. We'll quickly add some fillets before we move on to creating the tip of our part. First, we'll need to create a new plane to mark where the tip will be. We can do so by using the plane command and selecting the face we wish to offset. We will go through with an offset of 5 mm. Now, we will create a new sketch on the offset plane and create a circle centered at the origin. To bridge this sketch and our rectangular finger face, we will use the loft command. It allows for the creation of smooth transitions between different cross-sections inachievable with other tools. It is even possible to adjust this transition by adding start and end profile conditions. If we want the transition to start tangent to the walls of our finger, we can select the normal to profile condition. Or if we want the transition to be tangent to the face from which it begins, we can instead go with tangent to profile. We will go with a normal to profile start condition since it looks nicer, and apply a tangent condition to the end so it smoothly connects to the circle. Now our finger looks much better. Now we will quickly make a slot and hole in the tip so that we have an attachment point for the actuating cord. You could try recreating the sketch based on these measurements, or follow the sped up steps. Now we will remove 1 mm of material to create a channel and make a hole through the part for the attachment point. To make the channel on the other side of the part, we will use the mirror tool located right here. We will use the top plane to mirror the extrude feature that created the channel. Now our tip is done, and we will copy its part studio to create the final element. We will remove the loft and reduce the hole extrude to 1 mm before we get started. To create the last element, we will simply extrude the tip copy to the plane we created earlier and mirror the geometry itself around the plane. Now, all we need to do is to assemble our finger. We will go to the assembly environment and get our parts in it by using the insert button above the feature list. I'm not placing them in any precise position because we'll work on that later. To fix the position of the parts, we will use various mates. To fix the base section in place, we will use a fastened mate to attach it to the origin. We will select the origin, then the middle of this face, and then fix the rotation of the part. Now this part is not going anywhere. Now, to attach the midsection, we will create a rotating mate, also known as a revolute mate. We will select the pin location of both parts and offset the midsection by 1/8 of a millimeter to center it. Now we'll finish it off by doing the same for the tip. Our finger's 3D design is complete and you can explore its movement. It's good to assemble parts in CAD like that, so we can see if they can move in the desired manner. Congratulations on following through and completing your finger. You now have the knowledge you need to explore the full capabilities of Onshape and create amazing parts on your own. In the remaining tutorials, you will learn more about the software you'd expect to see in robotics, and also manufacturing and getting our finger to work along the way. Thank you for watching and see you in our next video.